Oh, that's much better now. So I'm playing Capture the Flag contests. Those are security-related contests in Just Cut the Fish team. I'm working for Trail of Bits, and I'm doing some open source developments. Okay. So when I was developing this this talk, I was thinking about like few approaches to this talk, and so I kind of matched all of them. So the first part of the talk will show like different things that you could think about when doing code review. So first of all, when people come from C-like languages to Python, they usually write their loops like this. So when you want to get an item from a collection, you would probably do something like this, but that's not the Pythonic way. The Pythonic way would be this thing, but there is a catch, because the first version also gives you the index of the item, so you can use enumerate to get it. Second of all, Python has a lot of batteries, so first of all, there are collections. There are also like all fancy built-ins like map, zip, reduce, iter tools, or func tools, and all the cool modules that you can download from PyPy, like request or Django, and so on. Another thing is design patterns and principles like solid, dry, keys, or Yagni. And there is also a cool talk, stop writing classes, because Python is apparently not Java. So you don't need like tons of classes in Python. Another thing is tooling. You probably use continuous integration. If you don't use, you probably should. So there are a lot of tools. One type of tool could be like some linters. There is, for example, MyPy for static typing, which is pretty cool because you can check whether the given type you want to be there can be like asserted. There are also like tools for styles, so you don't waste your time on code reviews on things like white spaces or other issues like this. So there's Pylint and Black, which is pretty cool. And there is a very good tool called Bandit, which is a security analysis tool that statically analyzes your code and tell you, oh, this is probably dangerous, you should review this. There are other tools you could use for code review or code review related things like editor config. This is like a plugin for all the IDs that would make your style consistent across different developers. And obviously use your shell, like test all the things in, for example, like Python. Another thing to mention about are Git commits. You probably want to have a cool, or rather straightforward and easy to follow Git history, because otherwise it would be hard to find things in it. So you probably should learn Git rebase. You probably should use force with list instead of force when you do Git push. And you probably should write proper Git commit messages. There are a lot of blog posts for that. So you don't want to make your Git commit looks like this, because this sucks. It says like nothing. Well, it says like there were some refactorings, but work in progress is not really a good commit message at all. You probably want something more like this, so we won't read it, but the thing is it's kind of descriptive what happened here in this commit, or what has been fixed, or what was the issue. So when someone does git blame, or git log, or git show, or something like this, he will find out what was the issue. Another thing is be a human. Like when you do code review for someone, you probably don't want to make them feel bad that they made some mistake or something. So try to be generous. Try to frame feedback as requests, not as comments. Because, well, you are there to improve your code, not to like blame people. Everyone makes mistakes. And that was enough from this like part. So the second part of the talk will be let's play. So let's do some reviews. The first example is this thing with regexes. So the question is, what does it do? Does anyone have any idea? You cannot answer this question because you saw this. Okay, but if you would rewrite it into something like this, so the thing here is that you could use the verbose flag whenever you compile a regex, and so this lets you to introduce comments inside of your regexes. that would inform user what's happening here. So this regex actually is there to match some kind of like character reference or actually number reference expression. So for example, this first line will match octal numbers like this. There is a prefix that must be there. The second line will be there for decimal numbers, and the third one would be for hex numbers. So the catch is there is a bug actually, and this example, like both of those examples, are actually from the documentation of Python, but there is a bug. Does anyone see it? Yeah, it's hard to spot actually. So the thing here is that if you would do 0.8, this like expression would be matched, while it shouldn't because it's not an octal form. Because octal form, right, it should start with 0, but it should be from 0 to 7. But this is matched because there is this 0 to 9 thing for decimal numbers. So this should probably be like 1 to 9 and then 0 to 9 and a star instead. Yep. So I would probably file them a pull request for that. Another example is this piece of code from one of the tools I develop. So the first thing here is that we have some class that inherits from abstract CPU, and this class implements an actual CPU. So it implements all the instructions inside of this CPU, like CMP or MOV. And so this abstract CPU has this execute method that is supposed to execute one instruction at a time. Or actually whole instructions, it depends on how it's written. So the first thing that it does, it gets the attribute of the instruction name. So for example, it gets this instruction.name is the string, is the name of the instruction. So it gets this attribute to get the function or the method actually, and then executes it providing the attributes or the operands, I mean arguments to the instruction. So whenever there is no instruction like this, it logs it out that this instruction is not implemented in here. And then it emulates this instruction using a different framework for emulation. Like not the code that we wrote to emulate the CPU, but some different framework. And there are also some other things, like whenever there is an interruption inside the machine or a syscall is called, the exception is thrown and a hook is applied to this exception. Yeah, and there's some event published whenever the instruction is executed, so other people can like provide their own hooks whenever something is executed. So the question is this code okay? Are there any bugs here or things that could be improved? What do you think? Yeah, it's kind of complex. Like there's a try in a try, which is controversial. That's true. Any other things? Yeah, it could be that there could be a better naming for the instruction, like as you said, instruction instead of INSN. While this actually is kind of discussive, like I mean, it probably would be okay for people that are like familiar with all this stuff. But you're right that it could be instruction. But another thing is that there is a bug here because what if the instruction itself, like CMP, move, or something like, or some other instruction, actually arises an attribute error? And attribute error is kind of common thing because you just want to get an attribute, and if you provide the wrong name of the attribute, it will raise the attribute error. So this try and except here is kind of wrong because it's super easy to provide this attribute error inside of an instruction implementation. So if this would happen, you would emulate the instruction instead of like launching your own code that could do something except of like just only launching the instruction. So as I said, this part is buggy here. And this could be changed, for example, into something like this. So we would get the attribute of the instruction, so we would retrieve the method. And then, if it's not known, then we call this implementation, and otherwise we log it and emulate it. Okay, let's go further. So we have code like this. So first of all, we have some, actually, this is like a class feature. This feature is, for example, like some AI feature that you would use in your some data science work. And the thing is that you want to serialize and deserialize it so that you can send it to some other component, because you might not want to do everything with it inside of Python. So you wrap this class, you wrap this data into a class, like feature, and then you put properties for each field. Because, well, first of all, you create it using the create method, like you create the feature and retrieve all the keyword arguments based on the field names. If there is no value for the field, you just default it to known, because we use get here, which is kind of might be wrong in some cases, but in this particular case it was okay. And you store it in a tuple. So this is kind of weird, because you write a class to use a tuple instead. So this is weird. But yeah, you write property for each of the fields, and then you have those serialize and deserialize methods that use the struct built-in module to actually pack it into some binary data or retrieve it from the binary data. Here is an example of packing and unpacking an integer of 32 bits. So as I said, this create method could probably be just changed into the init thing, which was probably obvious. Another thing is that, do you think it's okay here? Yeah, in Python 3.7 we could have used data class probably, but I don't have an example with data classes here. But yeah, that's a really good thing. So the thing is that, like, as I said, whenever you want to add a field here, you need to add it into the fields. You need to change your init module to like include this variable, and then you need a property for each of the fields, which kind of sucks because there are a lot of changes that you need to do. But the thing is, there is a much easier way to deal with such data in Python, because there is a ctypes module which is built in Python as well. And the ctypes module has, for example, little endian structure or big endian structure. The little and big endian like changes the way the data is stored. I mean, the ordering the data is stored inside of binary data. And so these ctypes things have those base classes that you just inherit from. You specify the fields, and you specify the exact types of the fields, as you can see, like uint64, 32, and so on. And the thing is that to serialize or deserialize your data, you don't even need methods. I wrote them here, but the thing is that to serialize things, you just use bytes, the built-in function in Python. And to deserialize, you can use ctypes.from buffer copy, for example. So you could probably provide it in a docstring, if like to make it easier for someone who is not familiar with ctypes. And the usage of this would look like this. So we instantiate the feature here. Then if we want to serialize it, we can just call bytes, and we would get the bytes of it. And if we want to like create a feature from bytes, we could do feature.from buffer copy, because this method is from ctypes, but it's given into it's inherited from the base class. And I actually used this _3, which works in IPython only. So this _3 here would map to this thing, to this third line. I mean, the output of the third line. Yeah, and the field maps like this, because there is uint64, 32, and 32. So the first one should be like double in length than the other ones. Okay, and the last example. So we have some table. This is like an abstract table. I mean, abstraction above some data storage that probably is not SQL, because it would, if it would be SQL, you would rather use some kind of like module downloaded from pip for that. So the thing is that we specify the table name, the column names. We have the init that takes the client that is connected to the database, I mean data storage. You open a table inside of this init, and then you have a scan method that lets you to apply some predicates, actually predicates based on the timestamp here. And the columns for this table are retrieved, like the column objects are retrieved by self.table and getting the I think index, like kind of index, getting item, I think, of the table thing. Then you create then you retrieve the tuples, and then you can map them into pandas data frame. This thing here could be written much more optimal, but let's not focus on that. But the thing here is, what do you think about this code? Is it good or bad? What can be improved? Any ideas? Okay. So the thing is that the column names are hard-coded, and it's a bit painful to add new columns, because whenever you want to add a new column, you probably need to add it into the mapping itself, because here from the scan you want to get all the columns in a given order. So here the order is preserved based on the column names there, and whenever you add a column name, you need to also add it here, which is kind of stupid. Another thing is, if the table itself is created by another component, like another process or whatever, you probably want to check the table schema during init. I mean, it might be good to do so. For example, you can do it like only in debug mode, because you want to test it in your tests, for example. And you probably want an abstract class out of it, because this is some table, like a specific one, but you probably want an abstract one for the scans and so on. And as I said, adding new column is painful because of this mapping thing. And this can be improved and changed into something like this. So you can create some kind of column getter and use the built-in operator module, which has item getter thing, when you provide some index, and this thing returns you a function that will retrieve a given item out of the thing that you put into it. So here I am retrieving the index of the column name first, and then I am returning this item getter thing. And here I am just retrieving all the column names using this column getter. And that's all. Thanks. Hope you enjoyed. Are there any questions? Yes?
Not really a question, but you mentioned that regex verbose flag, and you didn't tell that it doesn't only allow the comments, but it also ignores all white spaces in your regex.
Yeah, that's true.
Very important. Not in this regex because it doesn't match any white spaces, but in other regexes, it's a very big deal.
Yeah, that's true, because there's this many lines string actually. So yeah, the white spaces are excluded. Any other questions? Okay, so thanks.